In this problem, we're going to write linear and exponential equations based on the same starting point, but with differences in growth and decay. So a new charter school opened in 1980, everyone's favorite year. There were 860 students enrolled. Using function notation, write a formula representing the number n of students attending this charter school T years after 1980, assuming that the student population does one of the following things mentioned in the table. So to begin, we're going to say that there's 860 students enrolled, and the first type of change is going to be a decrease by 6.6% each year. So we've seen previously how exponential models are set up. You have your initial value times 1 plus or minus r to the power, in this case, t. So for us, it's going to be 860 times 0.934 to the t. So where does 0.934 come from? It comes from 1 minus the 6.6%, or 1 minus 0.066. That is where the 0.934 comes from. Similarly, in the next row, we have an increase by 7% each year. We're still starting with that 860. And so it's going to be our initial value 860 times 1 plus, for growth, the 7%. So that is 1 plus 0.7, giving us 1.07. The next example, we're going to decrease by 23 students per year. So this means year after year, we're just going to subtract 23. So anytime we have this repeated addition or repeated subtraction, that's going to be a linear growth. And so it's going to look like y equals mx plus b, right? So you have your slope, which is a decrease by 23, so negative 23. And that gets applied as multiplication to your independent variable t. And then you have to add to that your starting point, which for all of these is 860. In the fourth row, it remains constant. So nothing happens. Every year it's 860. And in the year 2075, it will be 860. So there's no growth, there's no decay, there's no slope, there's no exponent, just the 860. And then in the last example, we're going to increase by 65 students per year. So again, this is repeated addition. This is linear. This is growth. So we're going to have a y equals mx plus b style of equation. In this case, it's going to be 65. That's our increase, applied to our independent variable t through multiplication, and then adding to that the initial value of 860.